Good afternoon, guys. Today we'll be talking about the three-column classification in proximal tibia fractures. So, as you know about the proximal tibia, there are various classifications such as the Schatzker, the Hall and Moore, and the AO classifications, which all classify the proximal tibia fractures well. But they only classify and describe the fracture pattern in the sagittal plane. There is no, all of these classifications do not classify fracture lines which go through the coronal plane. So, for example, in the Schatzker classification, know that 1, 2, 3 are lateral condyle, type 4 is medial condyle, type 5 is bicondylar, and type 6 is with metaphysio-diphyseal dissociation. As you can see, all these fractures classify the fracture patterns in the, suppose this is the proximal tibia, I'm holding it like this, only in the sagittal plane. If there's a coronal split of the tibia like this, they are not covered in this classification, for example, the Schatzker classification. Coming to the three-column classification, and it was described by Luo et al. In 2010 when he found the weakness in the Schatzker classification, and it is a CT-based classification where the axial cut in the CT is taken at the level of the fibular head. Okay, so as you can see, so how do we draw these three lines which divide the proximal tibia into medial, lateral, and the posterior columns? So the first, we take the center of the intercondylar eminence, that will be the central point. From there we draw one line to the anterior aspect of the fibula head, another line running towards the tibial tuberosity, and then we can take a 120-degree angle from that line and draw this line. Or also what we can do is, there will be a structure called the posteromedial ridge of the tibia, or the PMR. We can draw a line from the center of the intercondylar eminence to the posteromedial ridge of the tibia. As you can see, this coincides with the line to the anterior head of the fibula. So originally it was only divided into medial, lateral, and the posterior column. This entire thing was one. But slowly over time, people found different fragments in the medial and lateral side of the posterior column. So they divided it into the posteromedial and the posterolateral. To draw this line, we just draw a line from the center of the intercondylar eminence to the posterior sulcus. Okay, so medial, anteromedial, anterolateral, posterolateral, and posteromedial columns. So yeah, coming to the mechanism of injury, how the fracture pattern tells us the mechanism of injury. So if the fracture occurs very anteriorly in the tibia, the anterior avulsion fractures, they are occurring in hyperextension. If they occur on the anterior columns, anteromedial and anterolateral, they are extension injuries. EX is extension. And if they occur in the posterior column, they are flexion injuries. And if they occur on the lateral condyle, they are valgus forces which cause the fracture. And if they occur on the medial condyle, they are varus forces. Now I'll explain this more in detail. So as we know, in a valgus force, the lateral condyle of the tibia impacts the lateral tibial condyle. So this results in a lateral tibial fracture in a valgus force. And in a varus force, the medial tibial condyle impacts the medial proximal tibia. So this results in a medial tibial plateau fracture. So you understand how valgus and varus forces affect the respective condyles of the tibia. Also, in extension, we can see that the contact point of the tibia and the femur is more anteriorly. As we flex the femur more and more, the contact point goes posteriorly because of femoral rollback. So as you can see here, in extension, the tibial and the femoral contact point is more anteriorly. As we flex, it goes more posteriorly, and as we hyperflex, the contact point becomes even more posteriorly. So this is why the hyperextension injuries are involving the anteriormost part, extension injuries involve the anterior column, and flexion injuries involve the posterior column. So if there's an extension valgus force, it will involve the anterolateral column. Flexion valgus force will involve the posterolateral column. Extension varus force will involve the anteromedial column, and the flexion varus force will involve the posteromedial column. So Coming to how we divide the fractures into 0 column, 1 column, 2 column, and 3 column. So a 0 column fracture is one where there's no clean cut fracture line, but there's only a pure articular surface depression with no fracture. With no fracture line causing a clean split. That's what I mean. So as you can see here is a clear depression of the lateral side of the tibia here on the sagittal view. Coming to the axial view, this is the coronal view. Coming to the axial view, you can see there is a depression in this region, but however there's no split separating it into a fragment. So this will be a 0 column. Coming to a 1 column, how do we say it's a 1 column? So any fracture that involves only the medial, lateral or posterior column with a fracture line disrupting the cortical surface of the column wall. So it should have a split fracture in any of the medial, lateral or the posterior column, any 1 column. So there's an exception to this. Suppose there's a lateral column fracture which runs from the anterior column and runs all the way to the posterior column, but it's one fragment. It's still regarded as a 1 column injury and not a 2 column, even though the fracture line is running through 2 columns. I'll show you with an example this exception. So as you can see here, this is a fracture involving the posteromedial column of the tibia. It's a separate fragment and this will require a buttress plating through a posteromedial approach in order to reach this fragment, because anything which is posterior to this line, the posteromedial ridge of the tibia, will be difficult to access in a regular medial approach. But if we use a posteromedial approach, we'll be able to buttress plate this. This will be a single column fracture. Now this is an example of fracture. In the coronal plane, you can see the fracture line running from here to here, splitting it as a CT 3D, which you can see it better. Here also you can see the fracture line running from the anterior column all the way to the posterior column, but it is a single fragment, so it is still considered a single column or a 1 column fracture. Whereas if there was another fracture line running here like this, separating it into anterolateral and posterolateral fragments, it would be a 2 column, but this is still a single column. 2 column fractures. So they 2 column fractures involve 2 of the 3 columns and must have 2 discrete fracture fragments, each of which have a separate fracture line extending into the involved column. So I'll just show you with an example. Like I talked about in the previous 1 column fracture, the previous fracture was just a single line running from here to here, anterior to posterior, but this has an additional fracture line running from this region towards the medial side. So this will be a posteromedial fragment and this will be an anteromedial fragment. There are 2 separate fragments, one involving the anteromedial column and the other involving the posterior column. So this will be a 2 column fracture. Coming to your 3 column fracture, same logic. There will be a separate fracture fragment in each of the 3 columns, the medial, lateral and the posterior column. That will be a 3 column fracture. So you can see there's one fracture here, there's one fracture fragment here, and there's one fracture fragment here. Posterior column, lateral column and medial column. So there's a separate fracture fragment in all 3 columns. So that'll be it for the 3 column classification. Thank you.